Hi everybody, I hope everybody's having a great day. So the next part of our triangles world is we're going to start talking about right triangles. Right triangles have a lot of properties about them, and we really want to make sure we are very clear on the difference between right triangle properties and then everything else we have learned. So I'm going to go ahead and highlight your title for me, please. Okay. And everything we have learned before in regards to triangle existence or congruent triangles or inequality or triangle inequalities or triangle similarity, all of that works with right triangles. Okay, these properties that we're going to learn in this unit only work for right triangles. So notice here it says given a right triangle I can label its parts. So let's label its parts. And I'm writing with a new program, so sorry if my handwriting is not very great. But remember, here's my 90-degree angle, and the angle the side that's always across to it is called the hypotenuse. My handwriting looks like a 5-year-old, but that's okay. And then the other two sides of my right triangle are called legs. Here's a leg, and here's a leg. Okay? So the hypotenuse is always across from the 90-degree angle. So you want to always keep that in mind. So the awesome thing about right triangles is you can answer a lot of questions about them. So, if I gave you a triangle that looked like this, and I said 1, we'll say 14, and we'll say 12. Is there any way I can figure out this angle? Excuse me. Is there any way that I can find this third side? I can't figure out this third side because I don't know what it could be. Okay? If I gave you angle measures, 53 degrees and 47 degrees, I could figure out this third angle because all angles in a triangle add up to equal 180 degrees. So it's really nice when you have a triangle with angles, you can figure out the third angle. But if I give you two sides of a triangle, you can't figure out the third side of the triangle. Okay? I can only determine the possible range. I could say, well, it has to be between 28 and 6. Anywhere between 6 and 28 would make this triangle exist. However, I don't know the exact number it could be. Okay? With right triangles, we have a way you can actually find the third side. How we do this is by using what's called the Pythagorean theorem. So if I scroll up, oh, and that didn't erase, but that's okay. We'll just keep scrolling here. So I can highlight where it says Pythagorean theorem. Okay. Pythagorean theorem was developed by a man named Pythagoras. Pythagoras was clearly self-centered when he named this theorem after himself. But what this theorem tells me is if I take the two sides of a right triangle, so if I were to take this leg and this leg, okay, I can create a relationship to find the value of the hypotenuse. And what this is they said a squared plus b squared equals c squared, where a and b are the legs, and c is the hypotenuse. Okay, so A and B, usually A is the smallest leg, B is the middle leg, and C is the hypotenuse. It really doesn't matter. I can call this A and this B, or I can call this A and this B. All that matters is that C is the hypotenuse always. That's always across from the 90-degree angle. Okay. The Pythagorean theorem was actually developed long before Pythagoras. It was developed in ancient Egypt times, or even ancient Greek and ancient Roman times. It's all been used. Nobody ever classified it until Pythagoras came around, which was actually in the ancient Greek times. So just kind of as a fun fact. So if we keep scrolling here, and I hate how it has this. Let's see if I can erase this. Nope, I can't. So I'm just going to leave that highlighted streak up at the top. So it says, determine if the following sides make a right triangle. So in order for a triangle to exist, a squared plus b squared has to equal c squared. Okay? So I'm just going to plug it into a formula. So I'm going to say a squared, which is 5 squared, plus b squared, which is 12 squared. I want to know, does that equal c squared, which is 13 squared? So 5 squared is 25, 12 squared is 144, 13 squared is 169. So 25 plus 144 is 169. So 169 equals 169? Yes. So I would say yes, a right triangle exists. Okay? Just for purposes of scrolling, let's jump over to number 4. Notice on 4, I don't know which one is A, B, and C. C is always what looks to be the hypotenuse. So which one of these values look to be the hypotenuse? Well, 26 does. So I'm going to assume 26 is C, and I strongly encourage that you label that's C, that's A, and that's B. If you wanted A to be 24, that's awesome too. It really doesn't matter as long as A and B are just the sides. So I'm going to set this up the same way. 10 squared plus 24 squared equals 26 squared. So 10 squared is 100. 24 squared is 576. And 26 squared is 676. I'm running out of room here. So 676 equals 676. Absolutely. So yes, a right triangle is formed. Okay. So let's keep scrolling here. Let's look at number 2. Number 2. Again, if I want to know if a right triangle exists, I'm going to do a squared, which is 6 squared, plus b squared, which is 9 squared, equals c squared, which is 10 squared. 6 squared is 36, plus 9 squared is 81, which equals 10 squared, which is 100. 36 plus 81 is 117. Notice 117 does not equal 100, so no, a right triangle does not exist. But notice if you go back, and I want to say, okay, well, does a triangle exist? The two smallest sides, 6 plus 9, is 17, which is greater than 10. So yeah, a triangle exists, but a right triangle does not exist. Right? So I want you to go ahead and pause the video, and I want you to try example 3 and example 5 on your own. But I'm going to keep going. So now I want to actually find examples of the missing value. So if I take a look at this, it says find the example of the third side. So all I'm going to do is I'm going to label 5 as A, 7 as B. I'm looking for C. So I'm going to do 5 squared plus 7 squared, because A squared plus B squared equals C squared. So now I'm going to clean this up. 5 squared is 25, plus 7 squared is 49, equals C squared. 25 plus 49 is 74. How do I get C by itself? I square root. So the square root of 74 is 8.6. If I asked you to write your answer in simplest radical form, I would have to say, okay, factors of 74. 74 divided by 2. 2 and 37. Both of those numbers are prime, so it'd just be the square root of 74. Okay. Let's go down and look at number 7. Again, I'm looking for C, so I have to label A and B. So 7 I'm going to say is A, and 10 I'm going to say is B. So 7 squared plus 10 squared, and I want to say does that to equal C squared. So I have 49 plus 100 equals C squared. So I have 149 equals C squared. So now I'm going to do 149, I'm going to do the square root of that. So C equals 12.2. If I wanted to write this in simplest radical form, I would try to break it up. And it doesn't look like I can. Okay. So now let's jump over to number 10. Notice number 10, this is C because it's across from the 90-degree angle. I'm looking for A, so that means 8 must be B. So now I kind of have to work backwards. So I'm going to say, okay, A squared plus 8 squared equals 14 squared. So A squared plus 64 equals 14 squared, which is 196. So now I have to solve for a. So I'm going to subtract 64 on both sides. I get a squared equals 132. And now I have to square root. So the square root of 132, 11.5. And I'm done. Okay. If I jump over to number 11, across from my 90-degree angle is always C, so I have B, so that means 11 must be A. So 11 squared plus B squared equals 18 squared. So I have 121 plus B squared equals 18 times 18, which is 324. So now I'm going to solve for B squared. That's a 4. This pen does not like me too much. So now I'm going to subtract 121. I get B squared equals 203. I'm now going to square root both of those. B equals 14.2. Okay. Hopefully you're able to follow along. And if I keep scrolling, and I want you to try these last 4 problems on your own. So go ahead and pause it. Notice these ones down here, before you pause, don't have A, B, and C as nicely as these ones do. So like if I just set up number 8 with you, across from my 90-degree angle, that's always C. And then it doesn't matter which one's A and B. So A and B. I usually do the little one as A and the bigger one is B, but it's totally up to you. The big thing to get out of this is to make sure that you know that these values are the legs and this is the hypotenuse. The legs are A and B, the hypotenuse is C. So go ahead and pause this video, try these last 4 problems on your own, and then we'll talk about them in class when we meet back together. We're going to keep going here. So it says here, using the Pythagorean theorem, we can determine, I don't want to use that color, gross. We can determine whether a triangle is acute or a triangle is obtuse. How we do this? So if C squared equals A squared plus B squared, then it's a right triangle. If C squared is less than A squared plus B squared, then it's an acute triangle. And if C squared is greater than A squared plus B squared, it's an obtuse triangle. Okay? If it's less than, it's acute. If it's greater than, it's obtuse. The one thing you have to pay very close attention is notice C squared is in the front. So you have to do C squared first on these. Okay? So if we look at some of these examples, notice, I don't know which one's A, B, and C, but C is always the hypotenuse, so the biggest value has to be C. So if that means 30 is C, so that means 18 is A, and 24 is B. So I'm going to set this up, and I'm going to say 30 squared, and I'm just going to draw a box, and then I'm going to do 18 squared plus 24 squared. So 30 squared is 900, my box. And then I'm going to do 18 squared, 324, plus 24 squared, 576. So now I'm going to do 900, and I'm going to do 576 plus 324. I get 900. So I'm either going to fill this box in with an equal sign, a less than sign, or a greater than sign. 900 is equal to 900, so since it's equal, that means it's a right triangle. Let's do the next one. We're going to jump over to number 4. Okay? So I look for my biggest measure because that's always C, and then the other two are A and B. So C squared always comes first, so 13 squared, and then A squared, 5 squared, plus 12 squared. 13 squared is 169. 5 squared is 25. 12 squared is 144. So now I have 169 and 169. Those are equal, so this is a right triangle. Okay, let's do one more together. So again, look for my biggest measure, that's 14, so that's c squared. And then 7 squared plus 12 squared. And yeah, I know, you can type all this in your calculator and do 14 squared. You get 196. And then you would type in 7 squared plus 12 squared, so 49 plus 144, that's 193. Okay? How does 196 relate to 193? It's greater, so when it's greater, that means it's obtuse. Okay? The biggest mistake you are going to make is you're going to accidentally do c squared at the end, and then it flips everything. So you have to be really super careful when you're doing this. Okay? So we're going to keep scrolling, and this is not sticking to it, so I guess I have to erase it, which I'm not great at, so let's just go ahead and start erasing. So the last part of this part of the unit, this topic that I want to talk about is word problems. So let's take a look at them. Oh, there we go. Oh, it's not working. Okay, there we go. It says there's a ladder leaning up against a house, and you want to find out how long it is without moving it. You see that the bottom of the ladder is 4 feet from the bottom of the building, and the ladder reaches to the top of the second-story windows, which is 18 feet high. Okay? So it says how long is the ladder? So this value right here is your ladder. So that I'm looking for is x. So it says the bottom of the ladder is 4 feet from the bottom of the building, so that's 4. And the ladder reaches to the second story, which is 18 feet high. So notice this forms a right triangle. You're given two sides. You have to find the third side, so I'm going to do the Pythagorean theorem. So x is c, 18 is a, 4 is b. So 18 squared plus 4 squared equals c squared. Okay. So 18 squared plus 4 squared is 340. And now I'm going to square root both of those. So c equals 18.4. So therefore, the ladder is 18.4 feet high. Okay? Remember, you start with words, you end with words. Okay? So we're now going to go to the last page. So go ahead and flip over to the very last page. And let's take a look at a couple more examples. So notice this one. This one says, you are standing in the woods. So here I am standing in the woods. 5 miles south of your camp. And 11 miles west of the Ranger's Tower. How far away are you camping from the tower? So this makes a right triangle. So how am I going to find that distance? I'm going to do the Pythagorean theorem. So this is C, A, B. So 11 squared plus 5 squared equals C squared. So 121 plus 25 is 146. So now I'm going to square root both sides. So C equals 12.1. So therefore, you are, no, not you, sorry, just kidding, not me. The campground is 12.1 miles from the tower. All right. So we're going to do one more. So look at this one. It says Johnny has 2 pieces of lumber and he wants to build a bike ramp with it. The longest piece used for the actual ramp, which is 8 feet, and the other piece was 6 feet, which will be used for the base or the bottom of the ramp. How tall will Johnny's ramp be? So obviously if here's a door and I'm trying to get into the door and I have a ramp, this is the ramp, and then it goes up like this. It's going to be some kind of triangular piece like here. It says the longest piece is 8 feet, so the actual ramp, so this is the actual ramp, okay? So that's going to be 8 feet. And it says the other piece is 6 feet, and I want to know how high the ramp is going to be. So, Pythagorean theorem. CAB, so 6 squared plus x squared equals 8 squared. So 36 plus x squared equals 64. 64 minus 36 is 28. Square root, square root. I get x equals 5.3. So therefore, the height of the ramp is 5.3 feet. Okay. So the expectation is that with the rest of this worksheet that you are going to go ahead and finish the rest of the problems. We will go over them in class when we return, and I hope everybody has a great day.